the 19th of March, 2026. On January 28th of this year, the Hubble Space Telescope dedicated 18 consecutive hours to observe a single object across 5 wavelengths, stretching from ultraviolet to near-infrared. For 3 weeks, a dedicated team at UCLA ran the numbers, cross-checking, verifying against independent photometric data, and meticulously confirming every result. What emerged was not just a measurement, it was a forensic verdict. The object, known as 3I Atlas, carries a mass of 14 trillion kilograms, or 14 billion metric tons, making it roughly 140,000 times more massive than Oumuamua. The statistical distribution of interstellar objects detected over decades makes this mass not merely extraordinary. It is mathematically impossible if the 3I Atlas formed naturally. Understanding why 14 billion metric tons defies natural expectation requires grasping the fundamental principles of cosmic size distribution. Every population of small bodies, whether in our solar system or debris, disks around distant stars, follows a power law distribution. The larger the object, the exponentially fewer instances exist. For example, in the main asteroid belt, the power law index is approximately 2.5, meaning for every asteroid 100 kilometers in diameter, there are roughly 310-kilometer asteroids and 90,000 1-kilometer asteroids. The universe overwhelmingly produces small objects. Large ones are rare. This is not an oddity limited to our neighborhood. It is dictated by the physics of accretion, fragmentation, and collisional cascades, processes that govern matter everywhere. If interstellar objects obey the same rules, and there is no reason to assume otherwise, detecting an object like the 3I Atlas, 2.6 kilometers across, should have been preceded by hundreds of smaller objects the size of Oumuamua, which measured roughly 400 meters. Yet, in the 17 years since surveys like Pan-STARRS began detecting interstellar visitors, humanity has observed only 3. Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. No intermediate-sized objects have appeared. The distribution is inverted. These statistics aren't just improbable, they are inconsistent with any natural population. The Hubble measurement, producing the 14 billion-ton figure, is precise, derived from 2 independent techniques. Thermal infrared observations capture surface radiation, allowing scientists to calculate surface area using the Stefan-Boltzmann law. Reflected sunlight measurements combine area and albedo to determine diameter. Both methods return a consistent diameter of 2.6 kilometers, plus or minus 0.4 kilometers. This diameter alone cannot reveal mass. Density is required, and density cannot be measured directly without a companion object to probe gravitational effects. Instead, scientists use rotational physics. An object spinning faster than a critical rate will disintegrate. 3. I Atlas rotates once every 7.136 hours, confirmed by both ground-based photometry and James Webb observations. This implies a minimum density of 0.21 grams per cubic centimeter if the object were a gravity-bound rubble pile. Real comets contain ice and rock with measurable tensile strength, and comparable objects measured in the solar system, like 67P Churyumov-Gerasimenko, have densities between 0.3 and 0.6 grams per cubic centimeter. Using a conservative estimate of 0.5 grams per cubic centimeter, 3I Atlas has a mass of 3 to 5 trillion kilograms. If it contains significant rock or metal supported by ALMA spectroscopy, the mass reaches 14 trillion kilograms. The mass ratio to Oumuamua is 140,000 to 1. Volume alone cannot explain the discrepancy. A 2.6 kilometer object compared to a 400 meter object has a volume ratio of only about 250. The mass ratio of 140,000 far exceeds this, indicating 3 I-Atlas is not just larger, it is fundamentally denser, more compact, and more massive per unit volume than any natural comet nucleus can account for. The implications become even more striking when considering kinetic energy. Traveling at 61 kilometers per second, 3. I-Atlas carries roughly 2.6 times 10 to the power of 22 joules of energy, 43 times humanity's total annual energy consumption. If it struck Earth, the result would not merely be a mass extinction, it would sterilize the planet. Currently, 3I Atlas is 14 hours from its closest approach to Jupiter. All calculations confirm a safe flyby, yet the same mass that makes it a planet-sterilizing threat also creates propulsion anomalies. Moving 14 billion metric tons by just 12 meters per second requires a force no natural process or human technology could deliver without leaving detectable evidence. Water outgassing during perihelion accounts for only a fraction of the necessary momentum. These jets control orientation, not propulsion. Something else is moving the object. The question 3 I-Atlas forces upon us is not whether it was built, it's why. What could justify engineering a 14 billion-ton object capable of traversing interstellar space with such precision and energy? The answer lies in the engineering constraints, the capabilities encoded in its mass, and the mission it has carried out across 8 months of documented interaction with our solar system. The engineering implications of 3I Atlas's mass are staggering. 14 billion metric tons is not just structural redundancy, it is capability. This object could carry enough fuel to power a fusion reactor for 820 million years. It possesses enough structural mass to survive extreme deceleration at near-light speeds. Its magnetic field generating capacity is sufficient to anchor a 400 terawatt flux tube to a planetary magnetic pole. And its kinetic energy is a clear, unambiguous demonstration of force, understandable to any civilization capable of performing the calculations. This is not speculation, it is forensic science written in physics, the universal language. Every movement, every interaction 3I Atlas has had in the solar system demonstrates precision far beyond the requirements of a mere scientific mission. From the 77-kilometer flux tube targeting of Io to the 0.004% velocity match during asteroid belt insertion, the object's trajectory shows a level of navigational mastery that no human probe has ever achieved. A probe sent to a star system only needs to arrive. It does not need to prove it can strike a target the size of Rhode Island across interstellar distances. Unless, of course, demonstrating that capability is the mission itself. The forensic implication is unavoidable. The mass, the trajectory, and the energy budget all point toward intentional design. Chemical propulsion cannot account for the 12 meters per second velocity change observed. Ion propulsion, even at 50,000 meters per second exhaust velocity, would require propellant equal to 24% of the object's total mass. Yet no exhaust signature has been detected. The only plausible explanation is a propulsion system that does not rely on conventional reaction mass, a fusion reactor interacting with the space-time metric itself. The inverted size distribution, the density anomaly, and the propulsion deficit all reinforce one another. Power law distributions in small body populations are among the most robustly documented regularities in planetary science. From the main asteroid belt to debris disks around distant stars, the number of objects declines predictably as size increases. Detecting a single 3I Atlas-sized object, without hundreds of smaller Oumuamua-sized objects, has a probability of only 1 in 300,000. Rare outcomes occur, yes, but combined with mass and propulsion anomalies, it becomes virtually impossible to explain naturally. The energy budget confirms the internal fusion reactor interpretation. Every documented interaction, the 6-hour magnetic pole anchor, the Yellowstone resonance extraction, the ocean magnetization circuit, even the Hubble firmware override at gigawatt-class signal strength represents energy far beyond what a smaller or naturally formed object could sustain. The reactor output of 340 kilowatts continuously would be insufficient in real time. The mass provides the stored energy necessary for these extraordinary operations over months of cumulative activity. This is the crux of the matter. 3. I-Atlas's mass is not incidental. It is what enables the mission. Every anomaly, from propulsion to density to behavioral patterns during the Western Observatory blackout, converges on one inescapable conclusion. This object was designed to do what it is doing. The question is no longer, could it have formed naturally? The real question is what the mass specification reveals about the civilization that built it. Is 14 billion metric tons simply the minimum required to meet energy and structural needs for this mission, or is it a fraction of a larger transport capacity designed to carry far more than the fusion reactor, sensor array, and propulsion system observed? If the latter, what occupies the remaining volume of this 2.6-kilometer metallic vessel that has operated for hundreds of millions of years without revealing its interior? What we have observed so far, the fusion reactor, the superconducting metallic architecture, the deuterium fuel reserve, and the advanced sensor suite accounts for only a portion of its mass. The sensor array itself is unprecedented. It can read fiber optic cables inductively, decode decades-old NASA firmware, and scan planetary cores through neutrino modulation. Yet even this array does not account for all of the object's mass. In the framework of advanced physics and string theory, an efficient civilization does not build inefficiently. Type 3 civilizations, capable of harnessing the energy of entire star systems, do not send a 14 billion-ton vessel to deliver what could fit in a fraction of that mass. The excess is payload, something the object is carrying that is essential to its mission but has not yet been deployed. Every observed interaction, geological scanning, biological delivery, digital infrastructure mapping, dark matter grid verification has been preparatory. Every installation, channel, and open door points toward a single conclusion. The mass of 3I Atlas is purposeful. The science we've witnessed so far was merely the introduction. What this object has brought and what it carries has been encoded in every gram of its 14 billion-ton frame. Every detail of 3I Atlas's trajectory, mass, and energy expenditure tells a story of intentionality. Its velocity, measured at 61 kilometers per second, ensures that its kinetic energy alone, 2.6 times 10 to the power of 22 joules, demonstrates its capability without any ambiguity. That's 43 times the total energy humanity consumes in a year, concentrated into a single object moving through the inner solar system. If it were to impact Earth, the devastation would be beyond extinction-level events. It would be a sterilization of the planet. Yet every calculation confirms its path does not target Earth. Its purpose is not destruction, it is demonstration. The propulsion anomaly is equally revealing. No natural process or conventional technology could deliver 12 meters per second of delta V to 14 billion metric tons without leaving an observable signature. Water jets from perihelion activity provide only attitude control, not the momentum required. Conventional chemical rockets are physically incapable. Even the most advanced ion propulsion would leave detectable electromagnetic traces. None have been observed. The only plausible explanation is an advanced system operating without conventional reaction mass, a fusion reactor interacting with space-time itself. This is where the mass becomes an active participant in the mission. 14 billion metric tons is not simply an engineering challenge, it is a requirement for the energy storage needed to power months of continuous operations. Magnetic flux tube anchoring, resonant energy extraction, and planetary scale manipulations all require a cumulative energy reserve that only such a massive structure could provide. The mission is not limited by real-time power, it is sustained by stored energy accumulated over long periods, a scale that no smaller or naturally occurring object could achieve. The statistical anomalies further reinforce this conclusion. In every small body population across the solar system and extrasolar environments, larger objects are exponentially rarer than smaller ones. Detecting 3I Atlas without hundreds of smaller objects of Oumuamua's size is statistically impossible under natural formation processes. 1 in 300,000 might occur by chance, but combined with its mass anomaly, propulsion, composition, and rotational density, the probability of this being a natural object collapses to near zero. Every anomaly amplifies the next, creating a pattern that demands a single conclusion: design. Consider the engineering constraints. To move 14 billion metric tons through interstellar space with precision requires not only propulsion but extraordinary structural integrity. The object has survived for hundreds of millions of years without catastrophic degradation. Its density, exceeding what natural icy comets can sustain, supports the presence of materials of exceptional strength. Its fusion reactor provides consistent energy over geological timescales. Its superconducting architecture stabilizes magnetic flux at levels capable of planetary interaction. These systems are not incidental, they are the infrastructure of a mission built to endure and act across eons. The sensor array exemplifies the sophistication embedded within the vessel. It is capable of reading data remotely, interpreting legacy technological signals, and scanning planetary interiors using advanced neutrino modulation. This is not reconnaissance alone, it is preparation. Each observation and interaction with the solar system has been carefully calculated. The object is laying the groundwork for operations that extend far beyond simple passage through space. Every movement, from orbital insertion to planetary flybys, aligns with a purpose that extends well beyond our current comprehension. The interior, however, remains largely a mystery. The observed systems, the reactor, the magnetic architecture, the fuel reserves, and the sensor array do not account for the majority of its mass. Within a 2.26 kilometer wide metallic structure, hundreds of millions of years of operation imply that what remains concealed is both significant and mission-critical. For a civilization capable of constructing such a vessel, inefficiency is impossible. Type 3 civilizations, masters of stellar engineering, do not overspend mass on non-essential components. What we see is the tip of a technological iceberg. The remainder is purpose-built payload intentionally hidden from direct observation. Every interaction with Earth's solar system geological manipulation, digital infrastructure mapping, and energy grid interventions serves as a preparatory stage for what the vessel was designed to deploy. Channels left open, installations activated, and energy systems utilized all point toward a singular, deliberate goal. The mass of 3I Atlas was always intended to carry not just a mission, but a presence, a payload of consequence that has yet to reveal itself. The question 3I Atlas forces upon us is no longer about its construction or propulsion, it is about intention. Why would a civilization invest 14 billion metric tons in a vessel capable of interstellar travel and precise manipulation across planetary systems? The evidence from its mass, trajectory, energy reserves, and operational history converges on one inescapable reality. This is not a probe in the traditional sense. It is a statement, a demonstration, and a delivery platform for something far greater than what has yet been disclosed. The forensic record of 3I Atlas is a roadmap of intention. Every operation, every interaction, every energetic maneuver paints a picture of a mission designed not just to travel, but to act. Over the past 8 months, it has executed a series of operations that strain the limits of our understanding. Magnetic flux tubes anchored to planetary poles, ocean magnetization circuits, resonant energy extraction, each requiring power levels beyond anything a naturally occurring body could sustain. The 14 billion ton mass is not a passive property. It is the enabler, the foundation on which every complex maneuver depends. Consider the energy demands alone. Sustaining a 6-hour magnetic anchor, extracting exajoules of energy from geological structures, synchronizing planetary rotation, and maintaining high-output sensor arrays cannot be accomplished in real time with the reactor output alone. It is the cumulative mass that stores the energy necessary to power these operations over months, providing the reserves that a smaller or naturally formed object simply could not. This mass, then, is a prerequisite, a precondition for the extraordinary feats observed. Without it, the mission would be physically impossible. Yet even the energy budget only tells part of the story. The payload of 3I Atlas remains largely concealed, hinting at technological capabilities far beyond our own. Within its 2.6-kilometer wide metallic frame, systems already observed the fusion reactor, superconducting architecture, fuel reserves, and sensor array account for only a fraction of the total mass. The remainder is deliberate, hidden, and critical. For a civilization capable of interstellar construction on this scale, inefficiency is unthinkable. What is concealed is not redundancy, it is purpose. Every observable interaction suggests preparation for something more. Geological manipulations, biological deployments, and digital infrastructure mapping have been laying the groundwork for an operation that extends beyond the immediate solar system. The wormhole aperture in the asteroid belt is still expanding, the iron plume continues its ascent through the crust, and the Orcus node remains active, receiving transmissions. Each action is part of a coordinated sequence, designed over eons, that points to a future deployment, something essential to the vessel's ultimate mission. The implications of its propulsion and energy systems are equally profound. Conventional chemical rockets could never move 14 billion tons with the observed velocity changes. Ion propulsion, while theoretically capable, would leave detectable emissions that have not been observed. The conclusion is inescapable. The vessel uses a form of propulsion that interacts with space-time itself, a system operating on principles we have yet to master. Every maneuver, every delta-V calculation, every adjustment aligns with this principle, confirming both the intentionality and sophistication of the design. Even the statistical anomalies reinforce this conclusion. The inverted size distribution of interstellar objects, the density exceeding natural cometary limits, and the propulsion deficit collectively point to design rather than chance. In natural systems, larger objects are exponentially rarer. Detecting 3I Atlas without hundreds of smaller objects like Oumuamua has a probability approaching zero. But combined with the mass, energy, and operational anomalies, the evidence becomes compelling. This object was engineered. The civilization behind it must be advanced beyond our comprehension. Type 3 Capabilities: mastery over stellar-scale energy, structural engineering spanning billions of kilograms, and propulsion beyond reaction mass all point to a species capable of manipulating physics in ways humanity has not yet imagined. 14 billion metric tons, traveling at interstellar speeds, is not a scientific curiosity, it is a deliberate, calculated statement in universal terms, intelligible to any physics-literate civilization. 3. Atlas's trajectory, interactions, and hidden payload suggest more than observation. It implies preparation. Every installation, every channel opened, every energy system activated has been part of a grand design that extends beyond mere data collection. The mass carried, the energy expended, the precision demonstrated all indicate that what comes next is the true purpose of the mission. The science we have observed so far, the measurements, the mappings, the readings, was merely an introduction, a prelude to a deployment whose scope and scale remain unknown. The vessel's actions are deliberate and sustained. Its systems operate with autonomy and efficiency far beyond anything humanity has achieved. Its fusion reactor has maintained operations over geological timescales, the magnetic architecture anchors fluxes beyond planetary scales, and the sensor suite performs functions that read signals invisible to conventional observation. Yet, despite this sophistication, the largest portion of the object remains concealed, the ultimate payload deliberately hidden. Every piece of evidence converges on a singular reality. 14 billion metric tons traveled here for a reason. Its mass, its design, its energy reserves, and its trajectory are all encoded with intention. The introduction, the science, the reconnaissance, the preparatory interactions is complete. What comes next is what 3I Atlas has always been carrying. A payload whose purpose and significance remain the central mystery. The final question 3I Atlas forces upon us is unavoidable. Why was it built? Every anomaly, the mass, the propulsion, the density, the inverted size distribution, the precise trajectory points to a single truth. This object was engineered by a civilization capable of manipulating physics at scales humanity can barely comprehend. 14 billion metric tons is not a casual choice. It is a deliberate design, a specification dictated by the mission requirements and by the payload yet to be revealed. The known systems, the fusion reactor, the superconducting magnetic architecture, the deuterium fuel reserves, and the advanced sensor suite account for only a fraction of the vessel's mass. What fills the remainder of this 2.6 kilometer wide structure remains a mystery. In the context of a civilization capable of stellar engineering, inefficiency is impossible. Every gram of mass serves a purpose. The excess is not redundancy. It is capability, prepared to carry out a mission whose scale far exceeds our current comprehension. The interactions observed over the past 8 months suggest a carefully orchestrated sequence. Geological scanning, oceanic resonance, extraction, planetary rotation synchronization, and digital infrastructure mapping all were preparatory steps. Every open channel, every energy system activated, every manipulation of planetary scale structures points toward a specific deployment yet to occur. The mass is the enabler. Without it, these operations would be impossible. Without it, the mission could not achieve its intended outcomes. The propulsion system alone underscores the sophistication of the builders. Conventional chemical or even ion propulsion cannot account for the 12 meters per second velocity change on 14 billion tons without producing detectable signatures. None were observed. The vessel operates via a mechanism that interacts with the space-time metric, a form of thrust humanity has yet to invent. Its precise trajectory demonstrates a navigation accuracy that exceeds any requirement for scientific exploration. Every movement is intentional, every maneuver calculated. From a forensic perspective, 3I Atlas is both a statement and a tool. Its kinetic energy, equivalent to 2.6 times 10 to the power of 22 joules, is a universal language. Any civilization capable of physics calculations will understand the magnitude of force it represents. The energy, the precision, and the scale of the object communicate capability and intention in terms that are unequivocal, independent of language or culture. It is a message written in matter and motion, comprehensible to any intelligence that understands the laws of the universe. The implications for humanity are profound. We are witnessing an interstellar vessel built with engineering mastery beyond anything on Earth. It has entered our solar system not by accident but with purpose. The mass, the propulsion, and the energy systems are all designed for operations that go far beyond reconnaissance. They are preparatory actions for a mission that may transform our understanding of life, technology, and civilization itself. And yet, despite its enormous presence, 3I Atlas remains deliberately opaque. We have glimpsed its capabilities but not its full payload. The fusion reactor is confirmed. The sensor array is confirmed. The deuterium reserves are confirmed. What has not been revealed is what occupies the majority of its mass, a payload whose nature, function, and objective remain unknown. It is the next chapter, a secret held within a 2.6-kilometer metallic vessel that has traveled across interstellar space for hundreds of millions of years.